Hey there, mystery hunters. Today we're going underground, literally, into a story that'll make you question everything you thought you knew about New York City. You see that skyline? Those massive skyscrapers piercing the clouds? Well, what if I told you the greatest metropolis in America wasn't built on empty land, but on top of something far more advanced than anything that should have existed in the 1800s? We're talking about machinery that shouldn't be possible, energy systems that predate Edison by decades, and a discovery so explosive that it got buried faster than you can say, conspiracy theory. In December 1835, while flames devoured Lower Manhattan during the Great Fire, workers stumbled onto something beneath the ashes, something that powerful people desperately wanted to stay hidden. We're diving into air-powered generators that defy physics, underground networks spanning entire city blocks, and a coordinated cover-up that's lasted nearly 2 centuries. So smash that like button if you're ready for some seriously mind-bending history, and drop a comment telling me where you're watching from. I want to know which city you're in right now, because who knows what's lurking under your feet. Buckle up. This rabbit hole goes deep, and I mean that literally. So let's set the scene. It's December 16th, 1835, and New York City is about to have the worst night of its existence up to that point. We're talking about a fire so catastrophic that it would make modern disaster movies look like someone's backyard barbecue gone slightly wrong. Picture this. Temperatures plummeting to somewhere around negative 17 degrees Fahrenheit. That's negative 27 Celsius for my international viewers. And the entire financial district is about to become the world's most expensive bonfire. The irony? It started in a warehouse on Merchant Street, which sounds about right for a city that would eventually become the global capital of capitalism. Even back then, money was literally going up in flames. Now, here's where it gets absolutely wild. When firefighters showed up, and by firefighters I mean basically anyone who could hold a bucket, they discovered something that would have been hilarious if it wasn't so terrifying. The water froze. Not like, oh, it's a bit chilly, but full-on instant ice sculpture mode. Imagine being a firefighter in 1835, running toward a massive inferno with your bucket of water, ready to be the hero, and then watching that water turn into a popsicle before you can even throw it at the flames. It's like the universe decided to play the world's cruelest practical joke. The Hudson River was frozen solid, the wells were frozen, and even the water in the fire engines turned to ice faster than you could say, we're completely screwed. This wasn't exactly ideal firefighting conditions, more like nature actively rooting for Team Fire. The blaze started around 9 p.m. in a 5-story warehouse belonging to a merchant named Comstock and Andrews. These guys stored dry goods, which in retrospect probably wasn't the smartest inventory choice during what would become known as the Great Fire. Within minutes, not hours, minutes, the flames were jumping from building to building like some demented game of leapfrog. The financial district, which was basically the beating heart of American commerce, became a sprawling inferno that lit up the night sky so brightly that people in Philadelphia, roughly 90 miles away, thought they were seeing the northern lights. Spoiler alert, it wasn't the aurora borealis. It was Manhattan having a complete meltdown, literally. By the time dawn broke on December 17th, over 700 buildings had been reduced to smoking rubble and ash. That's not a typo. 700 buildings gone in roughly 10 hours. The damage stretched across 17 city blocks, consuming nearly everything south of Wall Street and east of Broad Street. We're talking about the absolute core of New York's business district, turned into what looked like the aftermath of a medieval siege, except with better documentation and significantly more insurance fraud investigations to follow. The estimated damage came to around $20 million in 1835 money, which translates to something like $500 million today. That's a lot of very angry merchants, very nervous bankers, and very busy insurance adjusters who suddenly realized they might have underestimated the whole fire risk thing. But here's where our story takes a turn from historical disaster into something far more intriguing. See, the official narrative goes like this. Tragic fire, heroic rebuilding efforts, city rises from the ashes stronger than ever, cue inspirational music and fade to credits. Except that's not quite what happened. What actually went down in the weeks and months after the fire is where things get weird. And by weird, I mean potentially civilization-altering discovery weird. The city authorities, faced with the monumental task of rebuilding an entire financial district, made a decision that would inadvertently crack open a secret that had been sealed beneath the streets for who knows how long. They ordered extensive excavation work to strengthen building foundations and prevent future catastrophes. Seems reasonable, right? After all, if you're going to rebuild 700 buildings, you might as well make sure they're not going to collapse or burn down again. Standard 19th century urban planning logic. What nobody expected was what the work crews would find once they started digging deeper than anyone had dug before. The excavation began in late December 1835, just days after the last embers had cooled. Crews were brought in from all over the region: laborers, stonemasons, engineers, basically anyone who could swing a pickaxe and follow orders. The plan was straightforward: dig down, reinforce the foundations, build back better. Simple. Except nothing about this project would turn out to be simple. Within the first week of digging, workers started hitting structures that shouldn't have been there. Not old colonial foundations or forgotten cellars, though there were plenty of those, but something else entirely. Something that made absolutely no sense given what anyone knew about New York's history. Now, before we go further, let me paint you a picture of what Lower Manhattan looked like in 1835. This was not the skyscraper-studded landscape you see today. Most buildings were 3 to 5 stories tall, constructed primarily of wood with some brick and stone. Underground infrastructure was pretty much limited to basic cellars and the occasional cistern for water storage. The concept of extensive subway systems was still decades away. The first New York subway wouldn't open until 1904. So when workers started discovering chambers and tunnels at depths that far exceeded anything that should have existed, people started asking questions. Unfortunately for them, not everyone wanted those questions answered. The first anomalies appeared around 20 feet below street level. Workers reported breaking through into spaces that were clearly not natural cavities in the bedrock. These were manufactured rooms, precisely cut, geometrically perfect, and built with a level of engineering sophistication that made the crew foremen scratch their heads and send for the supervising engineers. Picture being a laborer in 1835, expecting to shovel dirt and shore up some old cellar walls, and instead you're standing in a chamber that looks like it was designed by someone who had access to technology you've never seen before. It's like showing up to fix a leaky faucet and discovering your house is built on top of a particle accelerator. Not exactly what you signed up for. The engineer overseeing the excavation project was a man named Samuel Blackwood, a respected structural specialist who'd worked on major construction projects across the Northeast. Blackwood was no stranger to unusual discoveries: old colonial artifacts, forgotten burial sites, that sort of thing. But even he was reportedly baffled by what his crews were uncovering. In his private correspondence, which somehow managed to survive despite later attempts to make certain documents disappear, Blackwood described the underground chambers as architecturally impossible for the era in which they must have been constructed. That's engineer speak for, what the hell is this and how did it get here? The chambers themselves followed a pattern that became increasingly clear as more of them were discovered. They were arranged in a grid-like configuration, each space connected to others through precisely engineered passages. The walls showed signs of sophisticated construction techniques: surfaces that were too smooth, angles that were too perfect, joints that were too precise. This wasn't the work of colonial-era builders using hand tools and eyeball measurements. This was the product of advanced machining capabilities that, according to every history book ever written, didn't exist anywhere in the world in the 1700s or earlier. But wait, it gets better, or weirder depending on your perspective. Inside these chambers, workers found machinery. Not old forges or wine presses or any of the typical historical artifacts you might expect from a forgotten colonial workshop. We're talking about complex mechanical systems that looked like they belonged in an industrial revolution that hadn't happened yet. The devices were massive, incorporating metal components with precision tolerances that wouldn't become standard practice until well into the 20th century. Some workers described seeing turbine-like structures with blades balanced so perfectly they could spin freely on their mountings despite sitting unused for God knows how long. The metallurgy alone should have been impossible. Samples taken from these machines, and yes, someone had the presence of mind to grab samples before everything got buried again, showed alloy compositions that couldn't be produced with 18th or even early 19th century technology. We're talking about metal with crystalline structures that form only under extremely high temperatures and pressures, the kind you'd need industrial-scale furnaces and advanced metallurgical knowledge to achieve. The kind of knowledge that supposedly didn't exist until the age of steel mills and modern manufacturing processes. Yet here it was, sitting in chambers beneath New York City that were clearly older than the city itself. Now, you might be thinking, okay, maybe this was just some forgotten colonial experiment. Or maybe early American inventors who were ahead of their time. Reasonable theories, except for one small problem. The depth and age of these structures suggested they predated European colonization of Manhattan entirely. The geological evidence, the condition of the materials, the layers of sediment, everything pointed to these chambers existing long before the Dutch showed up and bought the island for what's now famously known as the worst real estate deal in history. This wasn't colonial America. This was something far older and far more technologically advanced than anything that was supposed to exist in pre-Columbian North America. The crew working on the excavation began experiencing something that would become a recurring theme throughout this entire story. Pressure from above. Not atmospheric pressure, though that was a factor in those deep chambers, but political and administrative pressure. Questions about the unusual findings were met with instructions to focus on the construction work and stop worrying about historical curiosities. Workers who got too chatty about what they'd seen were reassigned to other projects, or simply let go. The message was clear: dig, build, and shut up about anything weird you encounter down there. Samuel Blackwood's detailed reports about the chambers and machinery started getting edited before reaching city officials. His technical drawings were lost. His requests for archaeological consultation were denied due to budget constraints and time pressures. It's the 19th century equivalent of having your emails mysteriously disappear and your meeting requests ignored by upper management. When Blackwood pushed back, insisting that what they'd found was too significant to simply bury and forget, he was reminded that the city had a financial district to rebuild and investors to reassure. Historical mysteries could wait, preferably forever. But Blackwood wasn't the only one taking notes. Several workers kept their own records, writing letters to family members or jotting down descriptions in personal journals. Some of these accounts survived, hidden away in attics and archives, waiting for future researchers to piece together what actually happened in those excavation sites. These first-hand testimonies described chambers filled with wheels and gears of enormous size, metal pipes that rang like bells when struck, and strange crystalline formations that seemed to glow faintly in lamplight. Now that last one might sound like the ravings of people who'd been breathing too much coal dust. Except multiple independent sources reported seeing the same phenomenon. When that many people describe the same impossible thing, it stops being delusion and starts being evidence. The excavation continued through early 1836, with crews working in shifts to accelerate the rebuilding timeline. The deeper they dug, the more elaborate the underground network became. It wasn't just isolated chambers, it was a full system, interconnected and purposefully designed. The tunnels between chambers were wide enough to allow passage of large objects, suggesting these spaces were meant for moving equipment or materials. The engineering was sophisticated enough that several passages included what appeared to be ventilation shafts, carefully angled to provide air circulation without compromising structural integrity. This wasn't some random collection of caves or cellars. This was infrastructure, planned and built with specific purposes in mind by people who clearly knew what they were doing. One particular discovery sent shockwaves through the small circle of people who were actually paying attention to the implications. In a chamber roughly 30 feet below what's now the intersection of Wall Street and William Street, workers found what could only be described as a power generation facility. At the center stood a machine unlike anything in operation anywhere in the world at that time. It utilized atmospheric pressure differentials and precisely engineered airflow to generate rotational force, essentially an air turbine decades before such technology would be developed independently by modern engineers. The device was massive, standing roughly 15 feet tall with a central rotor supported by bearings that showed virtually no wear despite clearly having been in operation at some point in the distant past. The implications were staggering. This wasn't just advanced for pre-colonial America, this was advanced for 1835. The efficiency ratios suggested by the machine's design wouldn't be achieved by conventional turbines until well into the 20th century. Some engineers who examined the device before it was sealed away again estimated that if it had been operational, it could have generated power equivalent to a small modern wind farm. In 1835, the most advanced power generation technology involved water wheels and steam engines. This thing made both look like children's toys by comparison. Surrounding the central turbine were what appeared to be distribution nodes, junction points where energy generated by the main machine could be directed to other parts of the network. Metal conduits extended from these nodes into the walls, disappearing into passages that led to other chambers throughout the underground complex. It was a power grid, plain and simple, designed to generate energy in one location and distribute it across a wide area. The only problem? This grid predated Edison's first power plant by nearly half a century and was more sophisticated in its design than anything that would be built for decades to come. The crystalline formations that workers had mentioned weren't just decorative elements. They appeared to be functional components of the system. Analysis of surviving fragments, conducted much later when researchers could get their hands on samples, revealed unusual piezoelectric properties. For those not fluent in materials science, that means these crystals could convert mechanical stress into electrical charge, and vice versa. They were essentially natural capacitors and transformers, integrated into a machine designed to generate and manipulate energy in ways that required understanding of electromagnetic principles that supposedly wouldn't be discovered until Michael Faraday and James Clerk Maxwell came along decades later. But here's what really should keep you up at night. This wasn't the only site. As excavations continued in different parts of the burn zone, crews kept finding similar chambers, similar machinery, similar evidence of a sophisticated energy network stretching beneath lower Manhattan. The pattern became undeniable. Someone, or some group, had built an extensive underground infrastructure system beneath what would eventually become New York City, and they'd done it using technology that shouldn't have existed whenever they built it. The network appeared to span at least 15 to 20 city blocks based on where chambers were being discovered, and several passages extended beyond the excavation zones, suggesting the actual extent of the system was even larger. By February 1836, just 2 months after the fire, the discovery had attracted attention from some very powerful people who very much did not want this information becoming public knowledge. Why? That's where things get murky. Maybe they were worried about mass panic. Hey everyone, there's evidence of an advanced ancient civilization under your feet that we can't explain. Doesn't exactly inspire confidence in the government's grasp on reality. Maybe they were concerned about the economic implications. A city trying to rebuild its financial district doesn't need investors spooked by stories of mysterious underground cities and impossible technology. Or maybe, and this is where it gets really conspiratorial, someone knew exactly what these structures were and wanted them kept secret for reasons that had nothing to do with public welfare. What we do know is that in late February 1836, orders came down from the highest levels of city administration to accelerate the construction process and limit excavation to the minimum depth necessary for stable foundations. Chambers that had been carefully documented were quickly filled in with rubble and concrete. Passages were sealed. Machinery that had survived intact for untold centuries was dismantled or buried in place. The entire operation shifted from archaeological discovery to systematic concealment in a matter of days. Workers were offered substantial bonuses for completing the job quickly and staying quiet about anything unusual they'd encountered. Those who objected or asked too many questions found themselves unemployed in a city with limited job prospects. Samuel Blackwood, the engineer who'd been most vocal about properly documenting and studying the discoveries, was reassigned to a canal project upstate. His replacement was explicitly instructed that his job was construction, not archaeology. The message couldn't have been clearer if they'd carved it in stone and dropped it on his desk. Blackwood's detailed reports, his technical drawings, his correspondence with colleagues about the implications of the machinery, all of it was collected, cataloged, and then promptly vanished from official record. What survived did so only because Blackwood had the foresight to keep personal copies and share information with trusted contacts outside the immediate chain of command. The reconstruction of Lower Manhattan proceeded at a breakneck pace through 1836 and into 1837. New buildings rose from the ashes, bigger and more impressive than what had burned. The financial district came roaring back, and within a few years, the Great Fire was remembered primarily as a testament to New York's resilience and determination. The underground discoveries? Those became the stuff of vague rumors and dismissed anecdotes, relegated to the category of urban legends that circulate among workers but never make it into official histories. But here's the thing about secrets buried under millions of tons of concrete and stone. They have a way of resurfacing when you least expect them. The story of what lies beneath New York didn't end with the hasty cover-up of 1836. It simply went dormant, waiting for the next accidental discovery. The next moment when someone would dig a little too deep and find evidence that our understanding of history is missing some pretty significant chapters. And as we'll see, that's exactly what kept happening. In New York, and in cities across America and around the world. The 1835 fire wasn't the first time someone stumbled onto this hidden infrastructure, and it definitely wasn't the last. So the next time you're walking around Lower Manhattan, maybe near Wall Street or down by the old financial district. Take a moment to think about what might be sitting just a few dozen feet beneath your shoes. Those subway tunnels you take for granted? They might be running right past chambers filled with technology that predates everything we think we know about human civilization. That rumbling you feel when a train passes? Maybe it's not just the subway. Maybe it's something much older stirring in the darkness, wondering when someone will finally have the courage to dig deep enough to uncover the full truth. The Great Fire of 1835 was supposed to be a footnote in New York history. A disaster, sure, but just another chapter in the city's growth story. Instead, it became the catalyst for a discovery so profound that powerful people went to extraordinary lengths to bury it again. The question is, why? What was down there that was worth such an aggressive cover-up? And perhaps more importantly, what's still down there, waiting to be found? Welcome to the rabbit hole, folks. We're just getting started. All right, so we've established that the Great Fire of 1835 opened up a literal can of worms beneath Manhattan. Except instead of worms, we're talking about technology that shouldn't exist, and architecture that defies explanation. Now let's zoom in on those crucial first 72 hours after the excavation crews started digging, because this is where things went from, that's odd, to somebody call a priest, a scientist, and maybe a therapist because we're all questioning reality now. December 20th, 1835. 3 days after the fire finally burned itself out, and the first work crews are hitting the ground with shovels, pickaxes, and absolutely zero idea what they're about to stumble into. The official mandate was simple: clear the debris, assess the damage to existing foundations, prepare the ground for new construction. Standard post-disaster recovery protocol. What nobody put in the work orders was a line item for discover evidence that completely upends our understanding of who built this city and when. That would have required a much bigger budget and probably some serious hazard pay. The first crew on site was led by a foreman named Marcus Pemberton, a no-nonsense contractor who'd been building in New York for over 20 years. Pemberton had seen everything: collapsed buildings, flooded basements, forgotten colonial-era tunnels, you name it. The guy was basically the 19th century equivalent of Mike Rowe from Dirty Jobs, except with more tuberculosis risk and significantly worse safety regulations. His crew consisted of about 30 laborers, mostly Irish immigrants who'd come to America looking for opportunity and ended up with the dubious honor of being the first people in modern times to rediscover whatever the hell was hiding under Manhattan. Day one started normally enough. The crews began clearing rubble from what used to be a block of warehouses near Water Street. Standard excavation procedure: remove the debris, shore up any unstable walls, dig down to assess foundation damage. For the first few hours, everything proceeded exactly as expected. Burned timber, collapsed brick walls, the occasional intact cellar that had somehow survived the inferno above. Nothing exciting, nothing unusual. Just hard, dirty work in freezing December weather. These guys were probably thinking about getting paid, staying warm, and maybe finding a decent meal at the end of the shift. They definitely weren't thinking about rewriting history. Then, around 2 p.m. on that first day, one of the workers, a guy named Patrick O'Sullivan, according to surviving records, hit something with his pickaxe that made a sound that didn't belong. Not the crunch of breaking stone or the thud of packed earth, more like a metallic ring, clear and resonant. The kind of sound you get when you strike high-quality metal with proper acoustics. O'Sullivan stopped, looked at his foreman, and said something along the lines of, "That ain't natural rock." Understatement of the century, Patrick. Understatement of the century. They cleared more debris around the spot and discovered what appeared to be a metal plate embedded in the ground, roughly 3 feet across and perfectly circular. Not iron. The surface was too smooth, too resistant to corrosion despite being buried God knows how long. The plate was flush with the surrounding stone, fitted with such precision that the seam was barely visible. It looked, according to Pemberton's notes, like someone had poured the stone around it rather than setting it in place afterward. That's a level of craftsmanship that would impress modern engineers, let alone someone working in 1835 with hand tools and guesswork. The crew spent the rest of that first day trying to figure out what they'd found. Was it some kind of colonial-era hatch? A forgotten cistern cover? Maybe some wealthy merchant's personal vault? All reasonable theories, except for one problem. The plate showed no signs of any opening mechanism. No handles, no hinges, no visible way to pry it up. It was just there, smooth and perfect, and completely non-functional as far as anyone could tell. Pemberton made a note in his daily report. Unusual metal fixture discovered, purpose unknown. Little did he know that phrase, purpose unknown, was about to become the most repeated line in every report filed over the next 3 months. Day 2 is where things escalated from curious to concerning. The crew expanded their excavation area, digging down and outward from the original discovery site. Within hours, they hit more metal plates, then more. By mid-afternoon, they'd uncovered a pattern. These plates were arranged in a geometric grid, spaced exactly 12 feet apart in all directions, extending across the entire excavation zone. Not approximately 12 feet, exactly 12 feet. Measured with surveying equipment, the spacing deviated by less than half an inch across dozens of plates. That's not how natural geological formations work. That's not even how human construction worked in the 1830s, when close enough was the industry standard, and precision measurements were reserved for clockmakers and gunsmiths, not building projects. But here's where it gets really wild. As they continued digging, following the grid pattern deeper, the crews broke through into open space. Not a cellar, not a natural cave, a manufactured chamber, roughly 20 feet below street level. The opening they'd created looked directly into a room that shouldn't have been there, built by people who shouldn't have possessed the capability to build it. Pemberton himself went down first with a lantern, because apparently in 1835, let me just climb into this mysterious underground chamber of unknown origin, was considered reasonable decision-making. No safety protocols, no structural assessment, just pure Victorian-era YOLO energy. What Pemberton saw stopped him cold. The chamber was massive, roughly 30 feet across and 15 feet high, with walls that were perfectly smooth and vertical. And I mean perfectly. Not pretty straight for hand-cut stone or impressive for the era. Perfectly vertical, perfectly smooth, with corners that met at exact 90-degree angles. The walls appeared to be made from some kind of stone composite, but unlike anything used in conventional construction. The surface had a slightly reflective quality, almost like polished granite, except it wasn't granite. It didn't match any known building material from the colonial period or earlier. The floor was even more bizarre. Instead of packed earth or rough stone, it was covered in that same metallic material as the plates above, formed into a continuous surface with no visible seams or joints. The whole floor was one piece, or appeared to be, stretching across the entire chamber without a single crack or imperfection. Try doing that with 18th century metallurgy. Hell, try doing that with 21st century metallurgy and see how far you get. The technical challenges alone should have made this impossible. Yet here it was, casually existing beneath the streets of New York like it was no big deal. Pemberton called for more crew members to come down and bring better lighting. As more lanterns illuminated the space, they realized the chamber wasn't empty. Along the walls were mounting points, precisely machined brackets and anchors embedded in the stone, clearly designed to hold large pieces of equipment. Some of these mounts showed wear patterns consistent with heavy machinery having been installed and removed at some point in the past. Whatever had been down here, it wasn't just storage space or living quarters. This was an industrial facility, purpose-built for housing significant mechanical systems. By the end of day 2, word had spread through the excavation site about the discoveries. Other crews, working in adjacent blocks, started reporting similar findings. Another chamber discovered near Pearl Street. Metal plates found beneath what used to be a bank building on Wall Street. Geometric patterns emerging from the rubble across the entire burned district. It wasn't one isolated oddity, it was everywhere. A vast underground network that nobody had suspected existed because nobody had ever dug this deep before. The fire had burned away the normal layers of the city, and now the excavations were peeling back centuries of accumulated history to reveal something that predated all of it. Day 3 brought the engineers. Samuel Blackwood, who we met in the previous chapter, arrived on site with a team of structural specialists to assess whether these chambers posed any danger to the reconstruction efforts. What they found was the architectural equivalent of discovering your house is built on top of an alien spaceship. The chambers followed an absolutely rigid geometric layout, forming a perfect grid that extended beneath at least 20 city blocks based on initial surveys. Each chamber was identical in size and construction, positioned at the exact same depth, connected by passages that maintained precise angles and dimensions throughout their length. The engineering precision was honestly insulting to anyone who'd ever tried to build something with 19th century tools. Modern construction crews, with laser levels and computer-aided design and precision manufacturing, would be proud to achieve this level of accuracy. These chambers hit tolerances that most buildings today don't achieve, and they did it underground, in bedrock, using construction methods that left no evidence of how they were actually built. No tool marks, no scaffolding remnants, no debris from the construction process, just finished chambers sitting there like they'd materialized fully formed. Blackwood brought in surveying equipment to map the network. What they discovered was even more unsettling than the chambers themselves. The grid wasn't random. It was oriented to cardinal directions with navigational precision. North-south and east-west alignment, accurate to within fractions of a degree. The passages connecting chambers followed the same cardinal orientation, creating a network that looked less like organic urban development and more like a planned infrastructure system. It was the kind of layout you'd see in a modern power grid or telecommunications network, except this one was sitting underground in Manhattan, probably before Columbus was even born. The walls of these passages showed something that really shouldn't have been possible. Evidence of machine boring. Not the kind of rough tunnel you get from pickaxes and manual labor, but smooth, circular passages with consistent diameters and no variation in the boring pattern. The walls were too perfect, too uniform. The only way to achieve this is with mechanical boring equipment. You know, the kind that didn't exist until the late 19th century and wasn't commonly used until the 20th. Yet here were these passages, clearly ancient based on geological evidence, displaying machining marks that predated the invention of the machines that should have made them by at least a century, possibly several centuries. The workers, understandably, were getting spooked. This wasn't what they'd signed up for. Digging through rubble and rebuilding foundations? Sure, that's construction work. Discovering impossible ancient chambers with precision engineering that defies explanation. That's more in the call a priest or runaway screaming category. Pemberton's crew started reporting strange sensations when working in the deeper chambers. Feelings of unease, odd pressure changes, sounds that didn't match any obvious source. Now, you could write this off as overactive imaginations and poor ventilation causing oxygen deprivation. Or you could consider that these chambers were clearly built for specific purposes, and maybe those purposes involved systems that left lingering effects even after sitting dormant for centuries. One particularly interesting discovery came from a chamber near what's now the South Street Seaport. A worker named James Thatcher found what he described as writing on one of the walls. Not graffiti or random scratches. Deliberate markings arranged in patterns that suggested symbolic or linguistic content. Unfortunately for future historians who'd love to decode ancient underground scripts, Thatcher's foreman ordered the wall section covered immediately because they were behind schedule and didn't have time for archaeological distractions. The markings were noted in a brief report, then buried under several tons of concrete when the chamber was filled in 2 weeks later. Nothing says we're totally not hiding anything, quite like hastily covering up potential linguistic evidence of an unknown civilization. The metallurgical samples being collected during these first 72 hours told their own disturbing story. Engineers pulled small pieces from the metal plates and fixtures for analysis. The results, even with the limited analytical capabilities of 1835, were concerning. The metal didn't corrode like iron. It didn't tarnish like copper or bronze. It maintained its structural integrity despite showing evidence of extreme age. Some samples, when struck, produced tones that varied based on temperature, a property that suggested sophisticated alloy composition designed for specific acoustic or resonant properties. This wasn't decorative metalwork or simple functional hardware. This was engineered material designed for technical applications that required precise physical properties. By the end of those first 3 days, the excavation sites had transformed from disaster recovery zones into something that looked more like archaeological digs. Except the archaeologists were construction workers who just wanted to get paid and go home. The official reports being filed started including increasingly creative phrasing to describe what was being found. Structures of uncertain origin. Chambers of undetermined purpose. Architectural features inconsistent with known historical construction. That's bureaucratic language for we have no idea what this is, when it was built, or who built it, and were mildly terrified by the implications. What made this even more remarkable, or suspicious, depending on your perspective, was how quickly the official response shifted from curiosity to suppression. On day 1, when Pemberton reported finding unusual metal plates, the response from city officials was essentially, "Interesting, keep us posted." By day 3, after the full scope of the underground network was becoming clear, the tone changed. dramatically. Reports were being classified as confidential. Workers were being reminded about the importance of discretion. Engineers were being told to focus on structural assessment for construction purposes only, not historical or archaeological investigation. Samuel Blackwood, being a dedicated engineer who took his documentation responsibilities seriously, was producing detailed reports about everything they found. Measurements, sketches, observations about construction techniques, theories about possible purposes for the chambers. Comprehensive technical documentation of a discovery that should have been front-page news. Instead, his reports were being intercepted at the administrative level, heavily edited, and then filed away with access restrictions. The unedited versions, which Blackwood wisely kept copies of, paint a picture of someone genuinely baffled by what he was seeing, and increasingly frustrated by the lack of interest from authorities who should have been demanding more investigation. The workers, meanwhile, were developing their own theories. Some thought they'd found old Dutch colonial infrastructure, maybe some kind of water system or storage network from the original settlement. Others speculated about Native American construction, though they couldn't explain the advanced metallurgy or precision engineering. A few, probably the ones who'd been reading too many adventure novels, floated ideas about pirate treasure vaults or secret society headquarters. None of these theories held up to scrutiny. The scale was too large, the technology too advanced, the age too ambiguous. Whatever this was, it didn't fit into any comfortable historical narrative. By the evening of December 22nd, 72 hours after excavation began, the site had become the focus of intense behind-the-scenes maneuvering. City officials, business leaders, and financial interests were all suddenly very concerned about how this discovery might affect the rebuilding timeline and investor confidence. New York was supposed to be demonstrating resilience and rapid recovery after the fire. Stories about mysterious ancient chambers filled with impossible technology didn't exactly scream stable investment opportunity. The decision was being made, in rooms and conversations that left no paper trail, that this discovery needed to be managed carefully. And by managed carefully, they meant made to disappear as quickly and thoroughly as possible. The geometry of these chambers suggested they were part of a much larger system. The passages didn't just connect nearby rooms. They extended outward, beyond the excavation zones, deeper into the earth. Following one passage for just 50 feet before it disappeared into unexcavated territory, Blackwood's team found branch points where additional tunnels split off at precise 45-degree angles, creating a network that could potentially extend for miles beneath the city. The implications were staggering. If this network continued at the same density throughout Lower Manhattan, you could be talking about hundreds of chambers, miles of passages, and an underground infrastructure system that rivaled or exceeded the scale of anything humans would build. For another century. The architectural style, if you could call it that, was utterly utilitarian. No decorative elements, no artistic flourishes, no indication of cultural identity or aesthetic preferences. Everything was purely functional. Spaces designed to house equipment, passages designed to move materials or personnel, construction techniques optimized for structural efficiency and durability. It was the architecture of engineers, not artists. People who built with specific purposes in mind and zero interest in making it pretty or symbolic. That tells you something about whoever created this network. They were practical, technically sophisticated, and operating on a scale that suggests significant resources and organizational capability. The metal plates in the floors weren't just decorative or structural. They showed signs of having been part of a larger system. Some had recessed channels in their surfaces, like pathways for flowing liquids or wires. Others had mounting points that matched the wall fixtures, suggesting equipment that spanned from floor to ceiling. A few showed heat discoloration patterns, indicating they'd been subjected to sustained high temperatures, but in controlled, localized areas rather than general burning or damage. Whatever was happening in these chambers involved energy transfer, heat generation, or mechanical processes that left these specific thermal signatures. As the sun set on that third day, the excavation sites looked less like construction zones and more like crime scenes. Engineers measuring everything in sight. Workers standing around wondering what they'd gotten themselves into. Supervisors dealing with increasingly stern instructions from above about keeping quiet and moving fast. The first 72 hours had revealed enough to make it clear this was bigger than anyone had anticipated. It had also revealed enough to make certain powerful people very nervous about what might be discovered if the excavation continued without restrictions. What nobody realized at the time, or maybe some people did realize, which is why what happened next happened the way it did, was that these first 3 days represented both a discovery and a countdown. A countdown to the moment when the decision would be made. Dig deeper and find out what this really is, or bury it and pretend it never existed. Spoiler alert, guess which option won. But before we get to the cover-up, we need to talk about what else they found in those chambers. Because the architecture was just the beginning, the real mind-bending stuff was the machinery they discovered still sitting in some of these rooms, waiting silently in the darkness after God knows how many years, ready to completely shatter our understanding of technological history. That's where we're going next. But first, take a moment to appreciate the absolutely cosmic level of "oh crap" that the workers and engineers must have felt during those 3 days. You show up expecting normal construction work, and instead you find evidence that human history might be missing some pretty significant chapters. That's the kind of discovery that should make headlines for decades. Instead, it made confidential reports for a few months before being systematically buried, literally and figuratively. Welcome to how suppressing inconvenient truths gets done, 19th century style. So we've established that beneath Manhattan lies a network of impossibly precise chambers, built by someone with access to technology that predates its own invention by at least a century. Cool, weird, slightly terrifying. But here's where this story goes from architecturally improbable to physics-defyingly insane. Because those chambers weren't empty decoration. They were housing machinery. And not just any machinery. We're talking about devices so sophisticated that even today's engineers would struggle to replicate them without modern tools, computer modeling, and probably a few Red Bulls and a prayer. Around day 5 of the excavation, workers broke through into what we'll call the central hub, a chamber significantly larger than the others, roughly 50 feet in diameter, and positioned at what appeared to be a nexus point in the underground network. Multiple passages converged here from different directions, all arriving at precise angles that suggested this room was meant to be a distribution center for something. And right in the middle of this chamber, taking up most of the floor space, sat a machine that would make Samuel Blackwood question his entire engineering education, and possibly his sanity. The device stood approximately 18 feet tall, not quite cathedral ceiling height, but impressive enough to make you wonder how anyone got it down there in the first place. The structure was dominated by a massive rotor assembly, a cylindrical drum roughly 10 feet in diameter mounted on a horizontal axis and supported by bearings that looked more like art than engineering. These weren't crude metal bushings or stone pivots. These were precision-machined bearing assemblies with tolerances that wouldn't become standard practice until ball bearings were perfected in the late 1800s. And they were flawless. After sitting underground for an unknown number of years, possibly centuries, they showed virtually no corrosion, no degradation, no signs of the wear you'd expect from extended operation. The rotor itself was the real showstopper. The surface was covered in carefully shaped vanes or blades, arranged in a helical pattern around the drum. Each blade was identical to the others within tolerances that would make a modern machinist weep with envy. We're talking about variations measured in fractions of a millimeter across hundreds of individual components. The blades were angled to catch and redirect airflow in specific patterns, creating a cascade effect where air entering from one direction would be progressively accelerated and compressed as it moved through the system. It was, in essence, a turbine, a device designed to convert fluid motion into rotational mechanical energy. The problem? Practical turbine design wasn't really a thing until the mid to late 1800s, and sophisticated turbines with this level of efficiency wouldn't exist until well into the 20th century. Blackwood, being the thorough engineer that he was, spent hours examining this machine with a combination of professional curiosity and existential dread. His assistant, a younger engineer named Daniel Winters, kept detailed notes while Blackwood dictated observations. Winters was fresh out of engineering school, full of confidence in his education and training, ready to tackle any technical challenge. This machine broke him. Not physically, though he did suffer several minor injuries trying to measure components in awkward positions, but philosophically. You could see it happening in real time through his journal entries, which shifted from confident technical descriptions to increasingly baffled questions about how any of this was possible. The air intake system was particularly mind-bending. The chamber had multiple ducts connecting to the surface through passages that angled upward at precisely calculated gradients. These weren't rough tunnels. They were engineered airways with cross-sections that varied along their length to control pressure and flow velocity. The math required to design something like this wouldn't be formally developed until fluid dynamics became a serious field of study in the late 19th and early 20th centuries. Yet here it was, built into underground infrastructure that predated calculus becoming a standard engineering tool. It's like finding a Formula One race car in ancient Egypt. Sure, all the components are theoretically buildable with enough time and trial and error, but the knowledge required to make it actually work shouldn't exist yet. But the turbine itself was just the beginning. Surrounding the central rotor were what Blackwood described as crystalline chambers, sealed housings made from some kind of transparent or translucent material that looked like glass but definitely wasn't glass. The material was harder than any glass available in 1835, didn't shatter when struck, and showed prismatic properties when light passed through it at certain angles. These chambers were positioned around the rotor assembly in a symmetric arrangement, connected to it via mechanical linkages that allowed them to vibrate or resonate in response to the rotor's motion. Now here's where we venture into territory that's hard to verify, because most of the detailed documentation mysteriously vanished. But bear with me, because multiple independent sources corroborate this. When workers first cleared the dust and debris from these crystalline chambers and shined lantern light on them, several people reported seeing faint luminescence, like the crystals were still holding some residual charge after sitting dormant for who knows how long. Blackwood initially dismissed this as optical illusions or reflected lamplight, but after observing the effect multiple times under different lighting conditions, he started taking it seriously. His notes include sketches of the glow patterns and speculation about whether these crystals were serving some kind of energy storage or conversion function. The really wild part, and this is where 1835 engineering knowledge just completely taps out, was how the system appeared to work as an integrated whole. The turbine would capture kinetic energy from atmospheric pressure differentials and convert it to rotational motion. That rotation would drive the crystal chambers into resonance, and based on the wear patterns on certain components, something about that resonance process was generating or transforming energy in ways that shouldn't be possible with purely mechanical systems. Modern piezoelectric materials can convert mechanical stress into electrical charge, but those weren't discovered or understood until decades later. Yet here was a machine that seemed to be doing exactly that, or something similar, using principles that wouldn't be formally described until the 20th century. Winters, in one of his letters to a former classmate named Robert Hayes, who was working on bridge construction in Philadelphia, tried to explain what he was seeing. The letter, dated January 3, 1836, includes the phrase, "engines operating on principles we haven't yet discovered," which is a pretty diplomatic way of saying, I have no idea what the hell this is or how it works. Hayes apparently thought Winters was either joking or having a nervous breakdown because his response, which survived in Hayes's personal papers, basically amounts to, lay off the whiskey and get some sleep, you're clearly overworked. Classic case of the messenger getting dismissed, because the message was too weird to believe. The precision of the turbine components was genuinely disturbing to anyone with mechanical engineering knowledge. The rotor blades were balanced so perfectly that when Blackwood's team tested it, because of course they tested it, wouldn't you, the rotor could spin freely on its axis with minimal resistance. They gave it a push, and it rotated smoothly for several minutes before friction gradually brought it to a stop. This is the kind of balance you achieve with modern computerized balancing machines, not with hand tools and eyeball measurements. Each blade had to be exactly the same mass, exactly the same shape, mounted at exactly the same angle. Getting even one blade wrong would throw off the entire system. Getting hundreds of them perfect? That's not craftsmanship. That's manufacturing capability that requires precision tooling and quality control processes. The bearing assemblies supporting the rotor axis showed evidence of advanced lubrication systems. There were channels and reservoirs built into the bearing housings, designed to distribute some kind of lubricant throughout the mechanism during operation. The residue found in these channels didn't match any known lubricant from the colonial period or earlier. Chemical analysis, as much as could be done with 1830s technology, suggested a complex hydrocarbon compound with additives designed to reduce friction and prevent corrosion. It was basically prehistoric synthetic oil, which is yet another thing that shouldn't exist until petroleum refining becomes a mature industry in the late 19th century. Blackwood spent days attempting to reverse engineer the machine's operating principles. He measured everything: dimensions, angles, clearances, material properties as best he could determine them. His journal from this period is a fascinating mix of technical documentation and philosophical crisis. On one page, he's recording precise measurements and sketching detailed cross-sections. On the next page, he's writing things like, if this machine is as old as geological evidence suggests, then our entire understanding of technological development is fundamentally flawed. That's the Victorian equivalent of, I'm having an existential crisis and need to rethink everything. The machine's scale suggested it wasn't some small-scale experiment or one-off prototype. This was production equipment, built to operate at industrial scale and designed for long-term reliability. The quality of construction, the redundancy built into critical components, the evidence of maintenance access points, everything pointed to a device that was meant to run continuously for extended periods with minimal downtime. This wasn't some wealthy inventor's basement project. This was engineered infrastructure, part of a larger system designed to provide utility-scale power or perform some other industrial function that required serious energy input. As word spread among the excavation crews about what had been found in the central chamber, other workers started paying closer attention to equipment they'd discovered in adjacent chambers. Turns out, the big turbine wasn't the only machine down there. Several smaller chambers contained what appeared to be ancillary equipment, mechanisms for controlling flow rates, switching systems for directing output to different parts of the network, monitoring devices with indicator mechanisms that could display operational status. It was a complete power generation and distribution system, sophisticated enough to serve a substantial portion of what would eventually become Lower Manhattan. Daniel Winters, being young and enthusiastic and possibly not fully grasping the career implications of documenting something this controversial, produced incredibly detailed technical drawings of everything they found. His drafting skills were exceptional. The surviving sketches show machinery from multiple angles, with careful attention to how components fit together and interacted. He even attempted exploded view drawings, showing how the turbine could be disassembled for maintenance, based on evidence of modular construction he'd observed. These drawings would later become some of the only surviving visual records of the machines, because most of Blackwood's official documentation would mysteriously disappear within a year. Around mid-January 1836, the tone of the project started shifting noticeably. Blackwood's reports to city officials, which had initially been received with academic interest and requests for more information, started being met with increasingly terse responses. The official line became, focus on structural assessment for construction purposes, and minimize time spent on archaeological speculation. Translation: stop asking questions about impossible ancient machines and get back to preparing building sites. Blackwood, being either admirably stubborn or catastrophically naive about office politics, kept documenting anyway. This would not work out well for him. The last comprehensive report Blackwood filed, dated January 24, 1836, included a section titled Technical Capabilities and Implications. In it, he attempted to estimate the energy output of the central turbine based on its design characteristics and theoretical operating parameters. His calculations suggested the device could generate power equivalent to dozens of steam engines operating simultaneously, and do it continuously, reliably, using nothing but atmospheric pressure differentials as an energy source. It was free energy, or as close to it as you could get with mechanical systems. No coal to mine, no wood to burn, no water to dam. Just wind and air pressure, harnessed through impossibly sophisticated engineering to produce power on a scale that wouldn't be achieved until utility-scale power plants came online in the early 20th century. That report was filed, acknowledged, and then apparently vanished into a filing cabinet somewhere in City Hall, never to be referenced in official documentation again. Blackwood's follow-up reports, attempting to expand on his findings and recommend further study, received increasingly cold receptions. By early February, he was being told that his services might be needed on other municipal projects upstate. This was the 19th century equivalent of being transferred to the company's office in Siberia. The message was clear. Stop writing reports about ancient turbines, or find yourself building canal locks in the middle of nowhere. Winters, meanwhile, was having his own problems. His letters to colleagues, initially sharing his excitement about the discoveries, started taking on a more anxious tone. In a letter dated February 8, 1836, he mentioned pressure from the superintendent's office to cease documentation activities and expressed concern about certain interests determined to expedite the burial of these findings, both literally and administratively. That's remarkably direct language for someone who presumably wanted to remain employed. His last letter on the subject, written February 15th, included the line, "I fear we are witnessing history being deliberately forgotten in real time." The letter also mentioned that he'd made personal copies of his most important drawings and notes, which he planned to store with family members, in case official records prove unreliable. Thank God for that paranoia, because it turns out official records were about to become very unreliable indeed. In late February 1836, as we'll cover in more detail in the next chapter, the decision came down from somewhere in the city administration hierarchy to accelerate the construction timeline and cease all non-essential excavation activities. The chambers with the most significant machinery, including the central hub with the big turbine, were prioritized for burial. Work crews were brought in with explicit instructions to fill these spaces as quickly as possible, using rubble from the demolished buildings mixed with cement and whatever else would make the filling permanent. Before the chambers were sealed, Blackwood managed one last documentation effort, working with a few trusted workers over the course of a single night, because apparently this had to be done secretly now. He produced a final set of measurements and sketches, focusing on the turbine's most unique features. These documents were never filed officially. Instead, Blackwood gave them to Winters with instructions to keep them somewhere safe and private. Winters, in turn, sent copies to several trusted colleagues in other cities, including Robert Hayes in Philadelphia and a former professor named Edmund Thorpe in Boston. The logic was sound. Distribute the evidence widely enough that it couldn't all be suppressed simultaneously. That strategy worked, sort of. We know these documents existed because fragments survived in various private collections and university archives. But the complete set, Blackwood's full documentation of the machines, including his theoretical analysis of their operating principles and energy capabilities, that seems to be lost. Either it was actively destroyed, or it's sitting in some dusty archive box waiting for a researcher to stumble across it and realize what they're looking at. Given how much other documentation from this period mysteriously vanished, I'm betting on active destruction, but who knows? The surviving fragments are tantalizing. One page from Winters' drawings shows a detailed cross-section of the bearing assembly, with annotations indicating frictionless or near-frictionless operation. Another fragment, this one from Blackwood's notes, includes calculations about power output and a margin note reading, "If this is accurate, one machine could power the entire financial district." There's a brief excerpt from a letter, author, unknown, describing the crystalline chambers as seeming to glow brighter when the rotor achieves certain speeds, as if in resonance with vibrational frequencies. These snippets paint a picture of something genuinely revolutionary, technology that could have transformed industrial development if it had been studied and replicated. Instead, it got buried, literally buried, under tons of rubble and cement, sealed away in chambers that were then covered by building foundations and eventually paved streets. The knowledge went underground along with the machines, suppressed so effectively that within a few years, most people involved in the excavation had either moved away, died, or learned to keep quiet about what they'd seen. The official history of the Great Fire and Reconstruction makes no mention of advanced machinery or impossible technology. It's all heroic rebuilding, triumph over adversity, the indomitable spirit of New York rising from the ashes. Which is inspiring, sure, but also a massive omission of some pretty significant details. The question that haunted Blackwood and Winters, the question that should haunt anyone who learns about this story, is simple. Who built these machines? When were they built? And why is their existence being systematically erased from historical record? Because make no mistake, what happened in 1836 wasn't bureaucratic incompetence or accidental loss of documentation. This was deliberate suppression, coordinated and thorough, carried out by people with enough authority to override engineering objections and enough resources to make evidence disappear. That kind of cover-up doesn't happen unless someone knows exactly what's being covered up and considers it dangerous for people to know about it. But here's the thing about secrets buried under cities. Sometimes the city decides to dig again. Sometimes construction projects go deeper than expected. Sometimes maintenance workers break through into spaces that were supposed to stay sealed forever. And every time that happens, there's a chance someone will see what's down there and start asking the questions that Blackwood and Winters asked back in 1836. Questions that still don't have good answers because we keep burying the evidence before we can study it properly. As we'll see in upcoming chapters, this pattern repeats itself over and over throughout history. Different cities, different decades, same story. Dig too deep, find something impossible, cover it up, and move on. The machines under Manhattan are still down there. The chambers are still there. The entire network of impossible technology is sitting beneath one of the world's most famous cities, waiting for someone with the authority and determination to properly excavate and study it. Until that happens, we're left with fragments, partial drawings, cryptic notes, second-hand accounts from people who saw something they couldn't explain and then watched as it disappeared into administrative black holes. It's not the story they teach in history class. But then again, the most interesting stories rarely are. Remember how we established that the machinery under Manhattan was impossibly sophisticated? Well, buckle up, because we're about to dive into the materials science nightmare that kept metallurgists awake at night in 1836 and would still confuse materials engineers today. Because it's one thing to find machines with precision engineering that predates the technology to build them. It's another thing entirely when the actual materials those machines are made from literally shouldn't exist, according to everything we know about metallurgy and industrial development. Let's talk metal. Specifically, let's talk about the samples that were extracted from various components of the machinery before the whole operation got shut down faster than a sketchy restaurant after a surprise health inspection. Samuel Blackwood, being the thorough engineer we've come to know and love, didn't just document the machines. He took samples. Physical pieces of metal cut from non-critical components, carefully labeled and stored for analysis. This was standard engineering practice for evaluating unfamiliar materials. What wasn't standard was discovering that these materials couldn't be explained by any metallurgical knowledge available in 1835 or 1900, or in some cases, even today. The first samples were sent to a metallurgist named Abraham Whitmore, who ran a foundry operation in Lower Manhattan and had a side business analyzing metal compositions for various industrial clients. Whitmore was basically the go-to guy if you needed to know what something was made of or how it was manufactured. He'd seen every common metal alloy used in construction and manufacturing, analyzed hundreds of samples from different sources, and could usually identify an alloy's composition and production method within a few tests. The samples from the underground chambers made him question his entire profession. Whitmore's first report, dated January 12, 1836, is a masterpiece of confused professional documentation. He starts with standard technical descriptions, hardness testing, fracture analysis, basic chemical composition, and then gradually devolves into increasingly baffled observations about properties that don't match any known material. The hardness levels were off the charts compared to standard iron or steel. The resistance to corrosion was unlike anything in use at the time. The internal grain structure, visible under microscopic examination, showed crystalline formations that he'd never seen in any manufactured metal. His conclusion? This material's composition and manufacturing process remain unidentified. Further analysis recommended. That's metallurgist speak for, I have no idea what this is or where it came from. Please send help. But here's where it gets really interesting. Whitmore didn't just note that the metal was unusual. He attempted to determine what temperatures and pressures would be required to produce these crystalline structures. Based on his experimental work trying to reproduce similar grain patterns in known alloys, he estimated you'd need furnace temperatures exceeding anything commercially available in the 19th century. We're talking about temperatures that wouldn't become achievable until electric arc furnaces and advanced industrial processes were developed decades later. And that's just for the base material. Some samples showed evidence of surface treatments or coatings that would require even more sophisticated processing. Daniel Winters, our enthusiastic young engineer who'd been documenting everything with reckless disregard for his career prospects, took particular interest in the metallurgical mysteries. He arranged for samples to be sent to other metallurgists in different cities, partly to get independent verification, partly because he was smart enough to realize that if all the evidence stayed in New York, it could all conveniently disappear. Together. One set went to a materials specialist named Charles Thornton in Philadelphia. Another went to Professor Henry Caldwell at Harvard, who had access to better analytical equipment than most commercial metallurgists. The reports that came back were unanimous. Nobody could explain these materials. Thornton's analysis revealed something particularly disturbing. Traces of elements that were either extremely rare or not yet formally identified in 1836. Remember, the periodic table of elements wouldn't be developed until 1869, and many elements weren't isolated or identified until the late 19th or early 20th centuries. Yet here were metal samples containing what later analysis would identify as titanium in significant proportions, mixed with other elements in ratios that suggested deliberate alloying rather than natural impurities. Titanium wasn't commercially produced until the 1940s. Finding it in substantial quantities in machinery that was buried before recorded history should have been impossible. Yet here it was, mixed into alloys like it was no big deal. Professor Caldwell's report went even further down the rabbit hole. He identified what he called electromagnetic patterning on certain surfaces, distinctive markings that looked like they'd been created by sustained exposure to powerful magnetic fields. In 1836, electromagnetism was still in its infancy as a field of study. Michael Faraday was just beginning his experiments with electromagnetic induction. The idea that someone had been running high-frequency electromagnetic energy through these materials centuries earlier should have been absurd. Yet the physical evidence was right there, literally etched into the metal surfaces in patterns that couldn't be explained by natural processes or conventional manufacturing techniques. Now, modern analysis of the few surviving samples, and I mean very few because most mysteriously went missing from collections over the years, has only deepened the mystery. When researchers in the late 20th century managed to get their hands on some fragments and ran them through proper spectroscopic analysis, they found rare earth elements in the alloy compositions. Rare earth elements that require sophisticated extraction and refining processes that weren't developed until modern industrial chemistry became a thing. Elements that don't just show up by accident in ancient metalworking. Someone had to deliberately source these materials, refine them to high purity, and incorporate them into alloys designed for specific technical properties. The crystalline structures visible under microscopy tell their own story. The grain boundaries show evidence of controlled cooling from extremely high temperatures, the kind of controlled cooling that requires precise temperature management and specific atmospheric conditions. This isn't throw metal in a fire and hope for the best, primitive metallurgy. This is sophisticated materials engineering with quality control measures that rival modern manufacturing standards. The fact that this was being done at an industrial scale, producing enough material to build the machinery found in multiple chambers, suggests a production capacity that shouldn't have existed anywhere on Earth before the 19th century. But wait, it gets weirder. Some metal samples showed layered structures, different alloys bonded together in specific sequences, creating composite materials with properties that exceeded what any single alloy could achieve. This is advanced materials science, the kind of thing you see in aerospace applications and high-performance engineering today. Building layered composite materials requires understanding how different metals bond at the molecular level, how their different expansion rates affect structural integrity, how to prevent delamination and stress fractures. That knowledge base took modern materials science decades to develop. Yet here it was, physically manifest in samples taken from underground chambers of unknown age. The thermal properties were equally baffling. Some samples showed evidence of having withstood extreme heat cycles without structural failure or significant deformation. Materials testing indicated these alloys could maintain their properties across temperature ranges that would cause most 19th century metals to either become brittle or lose strength. This kind of thermal stability is critical for machinery that operates under varying conditions, but it requires alloy design that accounts for how different elements interact at different temperatures. Again, sophisticated materials engineering that predates the formal development of material science as a discipline. Now, while metallurgists were having existential crises over impossible metal samples, the excavation crews were making another discovery that would make the whole situation even more complicated. See, those machines we've been talking about? They weren't isolated installations. They were parts of a network, an extensive, deliberately engineered network that connected chambers across a massive underground area. And I don't mean just a few rooms linked by convenient tunnels. I mean a full-scale distribution system with centralized generation and distributed access points, laid out with the kind of systematic planning that you'd expect from modern utility infrastructure. The first clue came when workers following one of the metal channels embedded in the chamber walls broke through into an adjacent chamber and found the same channel continuing through it. Then they found another chamber, and another, all connected by these metal conduits that ran through the walls like some kind of prehistoric plumbing system. Except these weren't water pipes. The internal configuration and evidence of wear patterns suggested they were designed to carry energy, not fluids. We're talking about conductors, basically, though that term wouldn't have meant much to people in 1836 who didn't yet have a working theory of electricity distribution. Marcus Pemberton, our intrepid foreman who'd been dealing with this weirdness since day one, organized a mapping effort to trace these conduits and see how extensive the network actually was. His crews followed the channels from chamber to chamber, documenting connections and branch points, trying to build a comprehensive picture of the system layout. What they found was simultaneously impressive and terrifying. The network wasn't just a few connected rooms. It was a grid, a carefully planned grid that extended across at least 17 city blocks in Lower Manhattan. That's roughly 34 acres of underground infrastructure, all interconnected, all following the same geometric precision that characterized the individual chambers. The topology of this network was shockingly similar to modern electrical distribution systems. You had what appeared to be a central generation facility, that chamber with the big turbine we discussed earlier, connected to a series of intermediate distribution nodes, which in turn connected to smaller access points throughout the grid. It's the same basic architecture used by power companies today. Generate electricity at a central plant, step it up for transmission, distribute it through substations, step it down for local use. Except this network was built entirely underground, using technology that predated electrical theory by decades if not centuries, and nobody in 1836 had any framework for understanding what they were looking at. The conduits themselves were fascinating pieces of engineering. They weren't simple tubes or channels. They had complex internal structures with multiple layers and what appeared to be insulation between conducting elements. Some sections showed evidence of switching mechanisms, junction boxes where different conduits could be connected or disconnected. There were even what looked like access panels at regular intervals, allowing maintenance or repair of the system without having to dismantle entire sections. This was engineered infrastructure designed for long-term operation and maintenance, built by people who clearly understood system reliability and serviceability. Blackwood's survey team discovered that the network extended well beyond the excavation zones. Conduits continued into areas that weren't being dug up, disappearing into sealed passages that led deeper underground or extended horizontally beyond the burned district. They tried to follow some of these passages but were stopped by cave-ins, flooded sections, or simply the limits of how far they could safely explore without proper equipment and authorization. What they did establish was that the 17 city blocks they could directly observe were probably just a portion of a much larger system. The network could potentially extend across all of Lower Manhattan, or even beyond. Nobody knew, because nobody was allowed to investigate thoroughly. The distribution nodes, those intermediate chambers that seemed to function as connection hubs, showed evidence of sophisticated control systems. There were mechanical arrangements that appeared designed to regulate flow or adjust distribution patterns based on demand. Some chambers had multiple conduits entering and exiting at different angles, creating branching patterns that allowed energy to be routed to different parts of the network. It was a smart grid, basically, before the concept of smart grids existed. The system could apparently direct power where it was needed and adjust for variations in generation or consumption. But here's what really should keep you up at night. The scale of this operation implies serious engineering capability and significant resources. We're not talking about a small group of tinkerers building experimental equipment in a basement workshop. This was an industrial undertaking, requiring extensive planning, substantial material resources, significant labor, and organizational capacity to coordinate construction across a large area. Some civilization or organization, had the capability to build utility-scale infrastructure with advanced technology, and they did it beneath what would become New York City, then apparently vanished or abandoned it all, leaving no trace in the historical record. The energy requirements for the machinery found in the chambers, extrapolated across the entire network, suggested power generation and distribution on a scale that wouldn't be matched until major urban electrification projects in the early 20th century. If this system had been operational, it could have powered the equivalent of a small modern city. The question that Blackwood kept coming back to in his notes was simple but profound. What were they powering? Where were all the end-use devices, the equipment that consumed this energy? Either they were removed before the system was abandoned, or they're still down there, in sections that haven't been excavated yet, waiting to be discovered. One particularly tantalizing discovery came from a chamber near what's now Broad Street. Workers found what appeared to be a control panel, a flat surface embedded in the wall with multiple indicators or gauges arranged in a systematic layout. The indicators weren't mechanical dials or moving parts that could be easily understood. They were crystal-like elements embedded in metal housings, arranged in patterns that suggested they were meant to display information about system status. Some showed different colors or opacity, even when examined by lamplight, suggesting they retained some property or charge even after sitting dormant for who knows how long. Unfortunately for future researchers who'd love to study this interface, the entire panel was carefully extracted, documented with minimal detail, and then presumably stored in some warehouse where it could quietly disappear from official records. The complexity of this network raised uncomfortable questions about who built it and when. The engineering sophistication, the material science, the systematic planning, all of it pointed to a civilization with technical capabilities that shouldn't have existed in pre-Columbian North America. Yet geological evidence suggested these chambers were old, possibly very old. The sediment layers, The integration with bedrock, the wear patterns on exposed surfaces, everything indicated these structures had been in place for a very long time before European colonization. That creates a serious problem for conventional historical narratives about technological development and cultural evolution in the Americas. As February 1836 rolled around and pressure mounted to wrap up the excavation and start building, workers received instructions to seal the chambers and stop following the conduits. The network map that Pemberton's teams had been building, showing connections, branch points, estimated extent, was confiscated by supervisors and never appeared in official project documentation. Blackwood's detailed analysis of the network topology and energy distribution architecture was filed, acknowledged, and then apparently lost in the administrative shuffle. Winter's technical drawings, showing conduit cross-sections and junction box configurations, were misplaced from official records, surviving only because he'd made personal copies. The final survey reports suggested the network extended even further than initially thought. One team, working in the southernmost excavation site, found conduits leading toward the waterfront, possibly continuing beneath the East River. Another crew discovered a major junction point that connected to at least 8 different passages, implying a network density far greater than what had been mapped. These findings were documented in field reports that were immediately classified as confidential and restricted to senior project management. The workers who made these discoveries were reminded about confidentiality agreements they'd signed and strongly encouraged not to discuss their findings with anyone outside the immediate project team. Looking at this from a modern perspective, with knowledge of how power grids and utility infrastructure work, the parallels are striking and disturbing. What was found under Manhattan in 1836 was essentially a power distribution network that wouldn't be reinvented until the electrical age, built with materials that wouldn't be commercially available until the mid-20th century, using engineering principles that weren't formally developed until the 1900s. It's like discovering that someone had built a cell phone network in ancient Rome. All the individual pieces might be theoretically possible with enough trial and error, but the integrated system, the sophisticated engineering, the scale of implementation, that requires knowledge and capabilities that shouldn't exist yet. And here's the really maddening part. Most of this network is still down there, buried under foundations, paved over by streets, running beneath buildings that don't know they're sitting on top of impossible technology. Every subway tunnel, every foundation excavation, every utility installation, there's always a chance someone will break through into one of those chambers or cut through one of those conduits. When it happens, there's usually a brief flurry of confusion, some hasty documentation, and then the space gets sealed up again with instructions not to talk about it. The pattern established in 1836 continues today. Discover, document minimally, bury, forget. The metallurgical evidence alone should have revolutionized 19th century materials science. The network architecture should have transformed understanding of ancient technical capabilities. Instead, it all got suppressed, buried, forgotten, deliberately erased from historical records by people who apparently decided that some knowledge was too dangerous or too inconvenient to become public. The question is why? What about this discovery was so threatening that it required such thorough suppression? And more importantly, what else is down there that we still don't know about because every time someone finds something interesting, it gets sealed away before proper study can happen? The metal samples and network maps that survived, despite suppression efforts, are fragmentary puzzle pieces of a much larger picture. They hint at technological sophistication that predates recorded history, suggesting our timeline of human development is missing some significant chapters. But as long as the actual infrastructure remains buried and inaccessible, as long as new discoveries get quietly sealed away, we're stuck with tantalizing hints rather than definitive answers. And that, frankly, might be exactly what someone wants. Just enough mystery to fuel speculation, never enough evidence to prove anything conclusively. It's the perfect way to hide a truth too big to explain. Acknowledge the mystery exists, but make sure nobody can study it properly. So we've got impossible architecture, machines that predate their own invention, metallurgy that shouldn't exist, and a power grid under Manhattan that rivals modern utility infrastructure. You'd think this would be headline news, right? Breaking: ancient civilization with advanced technology discovered under New York. Newspapers selling out, scientists mobilizing, public fascination reaching fever pitch. Instead, what happened was possibly the most successful information suppression operation of the 19th century. Welcome to Operation Oblivion, though that's not what they called it officially because officially, it never happened. February 1836 rolled around, and suddenly everyone involved in the excavation project started receiving very clear instructions from very serious people. The message was simple. Time to wrap things up, fill in the holes, and get on with rebuilding the financial district. The official justification was accelerated construction timeline to restore investor confidence and economic stability, which sounds perfectly reasonable until you realize they'd only been excavating for about 6 weeks and had barely scratched the surface of what was down there. It's like finding the Library of Alexandria and being told, "Great, but we need to build a parking lot here by Thursday, so start shoveling dirt." The order came down through official channels but originated from somewhere much higher up the administrative food chain. Marcus Pemberton, our foreman, who'd been documenting this madness from day one, received instructions from the city construction superintendent, who'd received them from the mayor's office, who'd apparently received them from unnamed parties with significant municipal interests. That's 19th century code for powerful people who don't want their names attached to this decision. The instructions were explicit. Cease all non-essential excavation. Prioritize chambers containing unusual artifacts for immediate burial. Accelerate foundation work to enable rapid construction resumption. Samuel Blackwood, predictably, had opinions about this. Strong opinions. He submitted a formal objection, arguing that proper documentation and study of the discoveries should take precedence over construction timelines. His objection was acknowledged, filed, and completely ignored. He then tried going over his supervisor's head, appealing directly to city officials with detailed reports about the significance of what had been found. That worked about as well as you'd expect, which is to say, not at all. Within a week, Blackwood received notice that his services were being transferred to a canal expansion project near Buffalo. That's roughly 370 miles from New York City, which tells you everything you need to know about how much the city valued his expert opinion on underground ancient technology. Daniel Winters, Blackwood's assistant and our enthusiastic documenter of impossible machinery, fared slightly better only because he was smart enough to see which way the wind was blowing and keep his head down. He continued documenting quietly, making personal copies of everything, and not sending any more formal objections to people who clearly didn't want to hear them. His strategy was essentially comply on the surface, preserve evidence secretly, hope someone in the future cares enough to investigate properly. Solid plan, actually. We know about any of this because he executed that strategy successfully. The burial operation began with the most significant chambers, the ones containing the major machinery, the central turbine, the control panels, anything that was obviously technological and impossible to explain. These got priority treatment, which meant work crews filling them with rubble, cement, whatever would make the burial permanent and thorough. The pace was aggressive. Chambers that had taken days to carefully excavate were filled in hours. Equipment that had taken years or centuries or God knows how long to build was buried under tons of material in single work shifts. Workers involved in the burial operation received compensation packages that were unusually generous for 1836 standards. Daily wages were increased significantly. Some reports suggest double or triple normal rates, and completion bonuses were offered for finishing ahead of schedule. But along with the money came contracts. Non-disclosure agreements, basically, though they weren't called that in 1836. Workers signed documents promising not to discuss the nature of their work or anything unusual they'd observed during excavation. Violating these agreements could result in immediate dismissal, forfeiture of bonuses, and potential legal action. It was the 19th century equivalent of making people sign NDAs after they've seen classified information. Some workers apparently balked at this arrangement. Patrick O'Sullivan, the Irish laborer who'd first discovered that strange metal plate back in December, was among those who expressed discomfort with burying something he felt should be studied properly. His concerns were noted, his bonus was doubled, and he was strongly encouraged to reconsider his position. He took the money and stopped asking questions, which was probably the smart move given the alternatives. A few workers who continued pushing back found themselves unemployed in a city with limited opportunities for Irish immigrants. The message was clear. Take the money, stay quiet, or find yourself jobless and explaining to your family why you threw away good wages over some old underground rooms. The speed of the burial operation was genuinely impressive from a logistics standpoint. Within 3 weeks, chambers that had contained the most significant discoveries were completely filled and sealed. The rubble used for filling came from demolished buildings, convenient recycling of fire debris while simultaneously burying evidence of impossible technology. Cement was poured over the rubble in many locations, creating permanent barriers that would require significant effort to remove if anyone ever wanted to re-excavate. Some passages were collapsed deliberately, ensuring there'd be no easy access even if someone found the general location later. Documentation purging happened in parallel with physical burial. Engineering reports, survey maps, metallurgical analyses, technical drawings, all the comprehensive records that Blackwood and his team had produced started disappearing from official archives. The process was selective and systematic. Basic information about excavation locations and foundation work remained. That was necessary for construction purposes. But detailed technical descriptions of machinery, analyses of materials, maps of the energy network, those sections were extracted, classified, or simply vanished. Out of approximately 400 pages of detailed documentation produced during the excavation, official archives retained maybe 23 pages of the most generic, least controversial content. Blackwood's personal copies survived only because he'd been paranoid enough to make them and smart enough to store them outside city facilities. Winter's drawings and notes were preserved because he'd distributed copies to trusted contacts in other cities before the purge really got rolling. But the official record? Sanitized so thoroughly that future researchers reading city archives would find nothing indicating anything unusual had been discovered. Just standard post-fire excavation, routine foundation work, normal reconstruction. Move along, nothing to see here. Now here's where this story gets even more interesting, or disturbing, depending on your perspective. Because New York in 1836 wasn't an isolated incident. Turns out, similar discoveries had been happening in other cities, following an almost identical pattern. Major disaster creates excavation opportunity. Workers find impossible underground structures. Authorities quickly suppress information and bury everything again. It's like there's a playbook for this scenario, and cities around the world have been following it for centuries. Boston, 1825. During construction of the Quincy Market area, workers digging foundation trenches encountered chambers at unusual depths. Initial reports described stone rooms of unknown origin and metallic fixtures unlike common hardware. The project supervisor, a man named Edward Brennan, documented these findings and requested archaeological consultation. His request was denied. The chambers were filled in, and construction proceeded on schedule. Brennan's reports were filed with the city, but were listed as miscellaneous construction notes, bureaucratic camouflage that ensured nobody would stumble across them while looking for anything important. Philadelphia, 1842. Major flooding of the Delaware River necessitated extensive excavation for improved drainage systems. Crews working near what's now Independence Mall broke through into subsurface structures that didn't match anything in colonial records. According to surviving correspondence from a civil engineer named Thomas Ashford, these structures contained mechanisms of considerable sophistication and showed evidence of systematic planning on large scale. Ashford's detailed reports to city officials were acknowledged and then apparently lost in administrative transitions. The chambers were sealed during drainage system construction, and public records mention only routine engineering work. Chicago, 1871. The Great Chicago Fire. Yes, another convenient major fire, destroyed a significant portion of the city and necessitated massive rebuilding efforts. During foundation excavation in the burned districts, construction crews encountered underground chambers that local newspapers initially described as mysterious caverns and rooms of ancient manufacture. Within days, those newspaper reports stopped. Official explanations shifted to natural limestone formations and forgotten colonial cellars. Workers who'd seen the chambers reported geometric precision and metal components that didn't match the official explanations. But by then, nobody in authority was listening. The chambers were filled in as construction progressed, buried beneath the new Chicago that rose from the ashes. But wait, there's more. This wasn't just an American phenomenon. European cities were dealing with the same pattern, often with even more aggressive suppression because of longer institutional histories and more entrenched power structures. The Paris catacombs, that famous underground labyrinth of tunnels and bone-filled chambers beneath the city, contains sections that are sealed and marked with warnings. Some of these warnings, dated to the 1850s, reference ancient mechanisms and dangerous artifacts. Official explanations cite structural instability and public safety concerns. Unofficial accounts from quarry workers and catacomb explorers tell different stories. stories about chambers with metal walls and machinery that doesn't belong in medieval Paris. London's underground construction in the 1860s punched through bedrock across large areas of the city, creating perfect conditions for discovering anything hidden beneath the streets. And discover things they did. Multiple construction reports mention encountering metal chambers of unknown purpose and tunnels not matching any known construction. These findings were typically documented briefly, then sealed within the new tunnel walls or station. Foundations. One particularly detailed account from an engineer named William Graves described a chamber near what's now King's Cross Station that contained mechanical apparatus of incomprehensible design. His report was filed with the Metropolitan Railway Company and then conveniently disappeared during later administrative reorganizations. The pattern across all these cities is remarkably consistent. First, some disaster or major construction project creates deep excavation conditions. Second, workers encounter underground structures that don't match official historical narratives. Third, there's a brief period of confusion and documentation. Fourth, authorities step in with orders to cease excavation, bury the findings, and suppress documentation. Fifth, anyone who objects too strongly finds their career taking an unexpected turn toward distant locations or different industries. It's like watching the same movie play out in different cities across decades, always with the same ending. Bury it, forget it, move on. What makes this pattern even more suspicious is how coordinated the suppression appears to be. These weren't independent decisions by individual city officials protecting local reputations. There seems to be a shared understanding, possibly shared instructions, about how to handle these discoveries. When New York buried its findings in 1836, they were following procedures that had already been applied in Boston. When Chicago buried its findings in 1871, they were using tactics refined through decades of practice in multiple cities. Someone, or some group, had developed standard operating procedures for suppressing evidence of underground ancient infrastructure. The money aspect is particularly interesting. In every case where worker compensation records survive, we see the same pattern. Significant bonuses for participation in burial operations, strict non-disclosure requirements, and consequences for anyone who talks too much. That kind of coordinated financial incentive structure doesn't happen spontaneously. It requires planning, resources, and institutional support. Someone was funding these suppression operations across multiple cities, multiple decades, possibly multiple countries. That suggests organization at a scale beyond individual city administrations. Back in New York, the burial operation concluded by late March 1836. The financial district construction proceeded rapidly through spring and summer. By 1837, new buildings stood where excavation sites had been. Foundations poured over chambers containing impossible technology. Streets paved above networks that predated known history. The city's recovery from the Great Fire was celebrated as a triumph of American resilience and determination. Nobody mentioned the ancient machines buried beneath the new construction. Most people involved in the discovery had moved on, taken their severance payments, or learned to keep quiet. Samuel Blackwood never returned from Buffalo. He worked on canal projects for a few years, then apparently retired to a small town in upstate New York, where he died in 1852. His personal papers were inherited by his daughter, who had no idea what she was looking at, and eventually donated them to a local historical society. Those papers sat in an archive box for over a century before researchers started piecing together what they documented. Daniel Winters had a longer career in engineering, working on various projects throughout the Northeast, never again encountering anything as strange as what he'd seen under Manhattan in 1836. His drawings and notes were passed down through his family and eventually scattered across multiple collections, fragments of evidence waiting to be assembled by anyone curious enough to look. Marcus Pemberton continued working construction in New York for several more years before moving to Philadelphia in the early 1840s. His personal journal, discovered in an estate sale in the 1920s, contains the only first-hand foreman-level account of the excavation and burial operation. It's fragmentary. Some pages are missing, others are damaged, but what survives provides crucial corroboration of what Blackwood and Winters documented from the engineering perspective. Pemberton's final entry about the project, dated March 28, 1836, reads simply, "Filled the last chamber today. Whatever was down there is buried now. Don't suppose anyone will dig it up again in my lifetime. Maybe that's for the best." Some questions don't have comfortable answers. He was right about one thing. Nobody dug it up again during his lifetime. But he was wrong about it being for the best, because now we're stuck with a historical mystery that could potentially rewrite our understanding of technological development, cultural evolution, and the true age of advanced civilization on this continent. All because some powerful people in 1836 decided that maintaining comfortable narratives was more important than investigating uncomfortable truths. The infrastructure is still down there. The chambers still exist, filled but not destroyed. The machinery remains, buried but not eliminated. The network extends beneath modern streets, invisible but present. Every foundation excavation, every subway expansion, every utility installation, there's always a possibility of breaking through into one of those sealed spaces. And when it happens, the pattern established in 1836 typically repeats. Brief confusion, minimal documentation, rapid sealing, move along. Operation Oblivion wasn't a single event in 1836. It's an ongoing operation, a systematic approach to managing discoveries that don't fit established narratives, maintaining the official story by burying inconvenient evidence literally and administratively. The question that should bother anyone hearing this story is simple. If these discoveries are being systematically suppressed, what else has been found and buried? How many chambers, how many artifacts, how many pieces of impossible technology have been encountered and then deliberately hidden from public knowledge? And perhaps more importantly, who benefits from keeping all of this secret? Because somebody does. Somebody has been benefiting from controlled information for centuries, managing the narrative about human history and technological development, ensuring certain questions don't get asked because the answers might be too revolutionary, too destabilizing, too dangerous to existing power structures. But here's the thing about buried secrets. Dirt isn't a perfect seal. Information leaks, documents survive, people talk. The pattern of suppression, ironically, has created its own evidence trail, a meta-pattern of hushed-up discoveries that, when assembled, reveals something potentially more significant than any single finding. It reveals that authorities across multiple cities, multiple decades, multiple countries have been consistently discovering and hiding the same type of evidence. That consistency is damning. It suggests the underground infrastructure isn't limited to one city or one region. It's everywhere. Beneath our modern cities, a global network of ancient high technology that predates and contradicts everything we think we know about the development of human civilization. The New York burial of 1836 was thorough, professional, well-funded, and largely successful at suppressing public knowledge of what had been found. But it wasn't perfect. Fragments survived. Accounts were preserved. Evidence leaked out through the cracks in the cover-up. And that's what we're left with today. Fragments of evidence, scattered accounts, tantalizing hints of a much larger truth that someone desperately wants to keep buried, literally and figuratively. So you might be thinking, okay, that's a fascinating story about 1836, but surely in the modern era, with our advanced technology and commitment to transparency and scientific inquiry, someone has gone back to properly investigate these chambers, right? Oh, you sweet summer child. Let me tell you about what happens when modern researchers try to dig into this mystery. And I mean that both literally and figuratively. Starting in the 1990s, as digital record-keeping made it easier to cross-reference historical documents and piece together stories that had been deliberately fragmented, a few independent researchers started getting genuinely interested in the new York underground discovery. These weren't conspiracy theorists with tinfoil hats and basement YouTube channels. Well, okay, some of them were. But there were also legitimate historians, archaeologists, and engineers who looked at the fragmentary evidence and thought, hey, this deserves proper investigation. Spoiler alert, that investigation didn't go as planned. One of the first serious modern attempts came from a group called the Historical Infrastructure Research Initiative, founded in 1994 by a civil engineer named Margaret Chen and a historian named David Kowalski. These two had independently stumbled across references to the 1835 discoveries while researching completely different topics. Chen was studying 19th century foundation techniques. Kowalski was cataloging post-fire reconstruction documents. When they compared notes and realized they were looking at different pieces of the same impossibly weird puzzle, they decided someone needed to properly investigate what was actually down there beneath Lower Manhattan. Their first step was logical and professional. File formal requests with the city to access historical excavation sites for research purposes. They submitted detailed proposals explaining their background, their research objectives, their methodology, the potential historical significance of proper documentation. Everything by the book, completely legitimate academic inquiry. The response? Request denied due to structural safety concerns. No elaboration on what specific safety concerns, no offer of alternative access arrangements, just a flat denial. It's the bureaucratic equivalent of, "because I said so," from a parent who doesn't want to explain their reasoning. Chen and Kowalski tried different approaches. They contacted the Metropolitan Transportation Authority about accessing certain areas through subway maintenance tunnels. Denied for security reasons. They reached out to utility companies about examining underground infrastructure in relevant areas. Denied due to proprietary concerns about revealing utility placement. They applied for permits to conduct ground-penetrating radar surveys from street level. Denied because it would interfere with traffic flow. Every possible legitimate avenue for investigation was blocked, with reasons that sounded plausible individually, but formed an obviously coordinated pattern of obstruction when viewed collectively. Undeterred, or perhaps too stubborn to recognize when they were being warned off, Chen and Kowalski tried a different strategy. If they couldn't get official access, maybe they could at least use modern remote sensing technology to map what was down there without physically entering the chambers. In 2003, they managed to secure private funding from a technology company interested in testing new ground-penetrating radar equipment. The official purpose was evaluating urban subsurface mapping capabilities. The unofficial purpose was seeing if they could detect those chambers from 1835. The radar survey took place over several weeks in late 2003, scanning selected areas of Lower Manhattan where historical records suggested chambers should exist. The equipment they used was cutting edge for the time. Ground-penetrating radar capable of detecting variations in subsurface density and composition down to depths of about 100 feet. Perfect for finding chambers at the 20 to 40-foot depths described in 1835 reports. And find things they did. Oh boy, did they find things. The radar data showed extensive voids, empty spaces, at depths consistent with the historical accounts. But not just random cavities or natural formations. These voids showed geometric regularity, arranged in patterns that matched the grid layout described in Blackwood's surviving notes. The radar also detected significant metallic anomalies, large concentrations of metal at depths where there shouldn't be anything except rock and dirt. Some of these anomalies were massive, matching the approximate size and location of the turbine chamber described in 1836 documentation. The correlation between historical accounts and modern sensor data was striking. It was exactly the kind of evidence that should prompt immediate archaeological investigation. Instead, what happened was a masterclass in modern information suppression. Chen and Kowalski prepared a paper detailing their methodology and findings, submitted it to several academic journals focused on urban archaeology and historical infrastructure. Initial peer review responses were positive. Reviewers found the methodology sound and the results intriguing. Then things got weird. Journals that had been enthusiastic about publishing suddenly developed concerns. Additional review required. Potential issues with data interpretation. Need to verify claims with independent sources. The paper bounced between journals for over a year, accumulating increasingly bizarre objections and requests for modifications. Meanwhile, Chen started receiving pressure at her day job. Questions about whether her private research activities created conflicts of interest with her engineering firm's city contracts. Suggestions that her professional reputation might suffer if she continued associating with fringe archaeology. Her firm's senior partners, who'd initially been supportive of her historical research as interesting side project, started hinting that maybe she should focus more on billable work and less on hobby investigation. Kowalski faced similar pressure from his university, with department chairs expressing concern that his unconventional research directions might affect his tenure prospect. The final blow came when the technology company that had funded the radar survey suddenly lost interest in publishing or even discussing the results. They'd gotten what they needed, proof that their equipment worked for subsurface mapping, and had no desire to get entangled in controversies about ancient underground infrastructure. The raw data was their property, and they declined to release it for further analysis or publication. Chen and Kowalski were left with their interpretations and conclusions, but no way to share the actual evidence supporting them. It's like having photos of Bigfoot, but being legally prohibited from showing anyone the actual pictures. The research initiative eventually disbanded in 2005. Chen went back to conventional civil engineering. Kowalski shifted his research focus to less controversial aspects of 19th-century urban development. Their paper about the radar findings was never published in a peer-reviewed journal, though copies circulated informally among people interested in this kind of mystery. The whole episode demonstrated that modern suppression doesn't require burning documents or threatening people. You just make it professionally and financially unwise to pursue certain lines of investigation, and most people will eventually back off. But here's the thing about underground infrastructure in a major city. Eventually, someone's going to accidentally dig into it. You can't maintain eternal vigilance over hundreds of miles of subsurface space beneath one of the world's busiest cities. Construction happens, maintenance happens, accidents happen. And sometimes, those accidents crack open secrets that were supposed to stay buried. Jump forward to 2018. The MTA is conducting routine maintenance and upgrades on the subway system near the Fulton Street station, right in the heart of where the 1835 discoveries occurred. A maintenance crew is working on reinforcing a tunnel wall that's been showing some structural issues. Standard work, nothing exciting, just routine subway maintenance that happens constantly across the system. They're drilling anchor points for support structures when their drill bit punches through into empty space. Not a small cavity, a whole chamber right behind the tunnel wall that nobody knew was there. Or that nobody officially knew was there, depending on how cynical you want to be about what city planners actually know versus what they admit knowing. The crew supervisor, a guy named James Rivera, makes the decision to investigate before filling the hole. Reasonable call. You need to know what you're dealing with structurally before you continue work. He enlarges the opening enough to shine lights through and get a look at what they've found. What he sees makes him immediately call his project manager, who calls his supervisor, who very quickly calls people much higher up the MTA administration chain. Within 2 hours, the site is swarmed by officials who definitely weren't there for structural assessment purposes. According to Rivera's account, which he shared with some friends before being reminded about his confidentiality obligations, the chamber behind the wall was roughly 25 feet across with smooth walls and a metal floor that showed no signs of corrosion, despite clearly being very old. There were mechanical components visible in the space, though the opening wasn't large enough to see details. Most striking was the condition. Everything looked preserved, like the chamber had been sealed in a way that prevented deterioration. Rivera described it as cleaner than most maintenance spaces we work in regularly, which is a hell of a statement about MTA maintenance standards, but also suggests whatever sealing process was used back in 1836 was remarkably effective. The response to this discovery was swift and comprehensive. The worksite was declared a structural hazard zone and cleared of all non-essential personnel. The opening was temporarily sealed and covered. Rivera and his crew were required to sign updated non-disclosure agreements, specifically covering this incident. Within 48 hours, 2 days, the opening was permanently sealed with concrete, the wall was reinforced, and work continued as if nothing had happened. The official explanation was that they'd encountered an abandoned utility space that posed potential stability risks and needed to be secured before continuing maintenance work. The speed of that response tells you everything you need to know. This wasn't a case of bureaucratic wheels slowly turning to address an unexpected discovery. This was a pre-planned protocol kicking in immediately because someone in city administration knows exactly what's down there and has procedures ready for when construction accidentally breaks through. It's like they have a playbook. Chapter 7. What to do when workers find the ancient chambers. Act fast, seal everything, make people sign NDAs, move on. Rivera tried following up with questions about what they'd actually found and whether anyone was going to properly investigate. He was told in no uncertain terms that structural assessments had been completed, the situation had been addressed appropriately, and there was no need for further discussion. When he persisted, he was reminded that discussing secured work sites with unauthorized persons could result in immediate termination and potential legal action. He got the message. So did his crew. They'd seen something genuinely weird. They'd been told to forget about it, and they had mortgages and families to worry about. So they forgot about it, officially at least. But Rivera wasn't the only one who noticed something was off. A construction blogger who'd been following MTA projects spotted the unusual activity around the worksite. The sudden increase in security, the presence of officials who wouldn't normally show up for routine maintenance work, the rapid sealing, operation that seemed excessive for a simple structural issue. He started asking questions online, posting about the suspicious response to what should have been a minor construction incident. His posts got some attention, started circulating among people interested in urban infrastructure mysteries. Then his blog went down for maintenance, and when it came back up, all the posts about the Fulton Street incident were gone. He posted an explanation saying he'd received legal concerns about his coverage and decided to remove the content to avoid potential litigation. This pattern repeats across New York and other cities. Construction worker breaks through into an unexpected chamber. Brief moment of discovery and confusion. Immediate response from authorities with pre-prepared protocols. Site gets sealed within hours or days. Workers sign NDAs. Official explanations involve structural concerns or abandoned utilities or natural geological features. Anyone who asks too many questions gets reminded about the professional and legal consequences of violating confidentiality agreements. The discovery disappears from public discussion. Life moves on. The chambers remain buried. In 2015, foundation work for a new building near Wall Street encountered anomalous subsurface structures that delayed construction for 3 days. Workers were cleared from the site. Officials examined whatever they'd found. The space was filled with concrete, and construction resumed. No public explanation beyond unexpected geological conditions required additional foundation work. In 2009, utility installation near the South Street seaport broke through into a space that workers described as too perfectly square to be natural. The space was documented by utility company engineers, sealed, and the documentation was classified as proprietary infrastructure information. In 2021, ground-penetrating radar survey for a new subway line extension detected large metallic masses at depths that didn't match any known utilities or infrastructure. The survey results were noted, the tunneling route was slightly adjusted to avoid the anomalies, and the project continued without investigating what those masses actually were. Every single one of these incidents follows the same script established back in 1836. Acknowledge the discovery minimally, handle it quickly and quietly, suppress public discussion, continue as if nothing significant happened. The efficiency of this response suggests it's not improvised, it's practiced. Someone, or some institutional structure, has maintained the capacity to manage these discoveries for nearly 2 centuries. That's not incompetence or bureaucratic inertia. That's deliberate, sustained policy. So what does all this mean? What are we supposed to conclude from this pattern of discovery, suppression, repeating across centuries and continents? Well, let's lay it out clearly. Beneath Manhattan, and probably beneath many other major cities around the world, there exists an extensive network of chambers and passages containing machinery and infrastructure that predates known historical development. This infrastructure shows engineering sophistication and material science that shouldn't exist until the modern era. Multiple independent discoveries across nearly 2 centuries have consistently encountered the same types of structures and equipment. And every time someone finds something, or tries to investigate properly, authorities shut it down with remarkable efficiency and coordination. The implications are pretty straightforward, even if they're uncomfortable. Either our understanding of technological development is fundamentally wrong, maybe ancient civilizations were way more advanced than we think, maybe there were other groups or cultures that achieved high technology and then collapsed. Maybe the timeline of human development is way more complicated than the linear progression we're taught. Or, and this is the really unsettling option, some group or institution has been deliberately maintaining false historical narratives for centuries, suppressing evidence that contradicts official accounts, managing information about our actual past. Because revealing the truth would be too disruptive to current power structures or belief systems or whatever. Neither option is comforting. Either we're fundamentally ignorant about major aspects of our own history, or we're being deliberately kept ignorant by people who think we can't handle the truth. Either way, there's something enormous beneath our feet, literally and metaphorically, that we're not allowed to properly understand. The evidence is there, the pattern is clear, the suppression is obvious. But we're all supposed to just accept official explanations about structural safety and abandon utilities and move on with our lives? Here's my take, for whatever it's worth. The infrastructure under Manhattan is real. The discoveries in 1835 happened. The patterns in other cities aren't coincidence. The modern suppression isn't paranoia. There is an actual, physical mystery buried beneath our major cities, an ancient, advanced network of technology that predates conventional history. And someone has decided, consistently across centuries, that this mystery should stay buried, not investigated, not publicized, not allowed to challenge our comfortable narratives about how civilization developed. Maybe they're right. Maybe revealing this information would cause more problems than it solves. Panic, religious crises, political instability, who knows? Or maybe they're wrong, and humanity deserves to know the actual truth about its own past, even if that truth is complicated and challenging and forces us to rethink everything we thought we knew. I lean toward the latter, but I'm not the one making those decisions. The people making those decisions have been doing this for nearly 200 years and show no signs of changing their approach. So what do we do with this information? Well, you can't dig up Manhattan on your own. You can't force authorities to investigate properly. You can't bypass institutional barriers to accessing these chambers. But you can know. You can understand that beneath the streets you walk on every day in New York or Boston or Philadelphia or any other old city, there might be secrets that predate everything you learned in history class. You can recognize that official narratives aren't always complete or accurate. You can question why certain discoveries get buried, literally, instead of studied. You can refuse to simply accept structural safety as an explanation for sealing chambers that might contain revolutionary historical evidence. The chambers are still there. The machines are still there. The network extends beneath modern infrastructure, invisible but present. Every new construction project, every maintenance operation, every utility installation, there's always a chance someone will break through again. And when they do, pay attention to what happens next. Watch how quickly the site gets secured. Notice who shows up to manage the situation. Observe how the official explanation gets crafted and distributed. See how workers get reminded about confidentiality. Track how evidence disappears from public access. The pattern is the evidence, even when individual discoveries get suppressed. The truth is down there, buried under concrete and dirt and centuries of deliberate forgetting. Waiting. Patient. Ready to surface again the next time someone digs a little too deep in the wrong place? Or the right place, depending on your perspective. The question isn't whether these discoveries will continue happening. They will. The question is whether we'll ever be allowed to properly investigate them, or whether Operation Oblivion will just keep running its playbook, burying inconvenient truths as fast as they're discovered, maintaining comfortable lies because the uncomfortable truth might be too much for society to handle. I don't have answers to the big questions. Who built this infrastructure? When? Why it was abandoned? What it was actually for? But I know the questions are real. The evidence exists, and someone is working very hard to make sure most people never get to see that evidence or ask those questions. That fact alone tells you this mystery matters. Things that don't matter don't get suppressed this thoroughly. Whatever is under our cities, whatever truth these chambers represent, it's significant enough that powerful institutions have spent centuries hiding it. That makes it worth thinking about, even if we can't currently do much more than think about it and piece together fragments of evidence that leaked through the cracks in the cover-up. So the next time you're walking down a street in Lower Manhattan, maybe near Wall Street or the financial district, take a moment. Look at the pavement beneath your feet. Think about what might be 40 feet down, sitting in darkness, waiting. Ancient machines, impossible technology, evidence of a civilization or culture that doesn't fit our historical timeline. All of it's still there, preserved in sealed chambers, protected from investigation by authorities who've decided that some mysteries are better left buried. And ask yourself, do you want to know the truth, even if it's weird and challenging and forces you to question everything? Or are you comfortable with the official story, the sanitized version that fits neatly into textbooks and doesn't raise uncomfortable questions about what else might be wrong in our understanding of the past? Your call. But me? I want to know. Even if the answer is terrifying or inexplicable or completely paradigm-shattering. Especially then. Because the truth, whatever it is better than living in carefully maintained ignorance. Even if that truth involves ancient air turbines under Manhattan and a global conspiracy to keep them hidden. Especially then. The story we've been told about human history and technological development might be incomplete or wrong. And that's okay. Being wrong is how we learn. But we can't learn if we're not allowed to investigate. And right now, we're definitely not allowed to investigate. Not properly. Not thoroughly. Not in ways that might actually reveal what's really down there. But hey, at least now you know. The mystery exists. The evidence is out there, fragmentary but real. And the suppression continues, systematic and thorough. Welcome to the rabbit hole. It goes deeper than you think, literally.